Right, the specimen NAB for Unit 3 Intermediate 2 Maths out of the Teejay book. Mr. Teejay thought it would be a good idea not to put the answers in, so I don't know what he was thinking there, but I'll go through them for my classes and anybody else who's interested. First question we have is here. We've got to simplify 3x plus 2, x minus 4 over x minus 4. It says x is not equal to 4. What does that mean? Well, it means that you cannot divide by 0. So on the bottom of the fraction we've got x minus 4. If you put 4 into there for x, you get 4 take 4, which would be 0. You cannot divide by 0. It's 0. It's like saying how many... It's like trying to do 7 divided by 0. How many zeros make 7? You can't do that question at all. No matter how many zeros you've got, you're never going to get 7. Anyway, back to the question. So we've got an x minus 4 on the top and x minus 4 on the bottom. Anything divided by itself is 1, so they just cancel out. And you're left with 3x plus 2. On to question 2. Again, we've got this p not equal to 0. P can't be 0, you can't do 7 divided by 0, you can't do 4 divided by 0. Your calculator would say undefined for that, that just means you cannot work it out. Right, 2a, 7 over p plus 4 over p. So we have a common denominator, so we'll just put the 7 plus the 4 over the common denominator of p. And 7 add 4 is 11, so the answer is 11 over p. Nice and easy, hopefully. Right, b got 5 over a minus 2 over b. Again, a and b can't be equal to 0, you cannot divide by 0 as I keep on saying. So here we need a common denominator before we add or subtract fractions. So I'm going to multiply the first fraction, the 5 over a, by b over b. b over b is really just 1. I'm going to multiply the 2 over b by a over a. And again, a over a is just 1, anything divided by itself happens to be 1. So there we go there, 5 over a times b over b, minus 2 over b times a over a. On the next page. So I've got common denominator of ab, be 5b minus 2a all over ab. On to c. m over 5 times 3n over p. Again, p can't be equal to 0. Denominator can never be 0. Doing questions like this is a simple case of the top multiplied by the top, the bottom multiplied by the bottom. Or find the product of the numerators and the product of the denominators. And there's your answer. So m times 3n, put the numbers first, is 3 times n over 5 times p. On to d, dividing by a fraction. Again, in this question, e and f cannot be equal to 0. For dividing by a fraction, we invert it. We invert the fraction we're dividing by, or in other words, you turn upside down at the second fraction and multiply. So we get d over 6 times f over e, which is df over 6e. So that one done. Number 3. Number 3, where's it gone? There it is. It says make c the subject of the formula. That basically means get c on its own. So here at the moment we have a equals b times c plus d. I'm going to subtract d from both sides. I will eliminate the d on the right hand side. So take d from both sides. We'll get a minus d equals bc. Now I want to get c on its own. At the moment we're doing b multiplied by c, so I'm going to divide both sides by b. And that b on the right hand side magically disappears because b divided by b is 1, so we're just left with c. A minus d over b equals c. And as we're making c the subject, c should be on the left hand side. So just swap them around. So c equals a minus d over b. On to number 4, the surds questions. Square root of 45. Simplify the square root of 45. Well, we know things like square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, etc. So what we're looking for here is a factor of 45 that is a square number. So 9 goes into 45. The reason why I'm picking 9 is I know that the square root of 9 is 3. So 9 goes into 45, so write that as a square root of 9 times the square root of 5. Notice the square root signs are still there. Square root of a times the square root of b is the square root of a times b. Now the reason why we do that, we know the square root of 9, that's 3, so we can write that as 3 root 5. There we go. Right, on to b. b is square root of 49 over 16. Now we can split this up to the square root of 49 over the square root of 16. And we know the square root of 49 is 7, the square root of 16 is 4. That just becomes 7 over 4. That's that done. It's a nice one for 2 marks. Next question, 5a. Got to simplify x cubed times x to the power 5 over x squared. X cannot be equal to 0, can't divide by 0, as I keep on saying. Right, thinking of that in longhand, x cubed is x times x times x. And x to the 5 is x times x times x times x times x. Over x squared is x times x. Now, anything divided by itself is 1, so one of the x's on top can cancel with one of the x's on the bottom. Another x on top can cancel with another x on the bottom. And we're essentially left with x multiplied by itself 6 times. So that's the longhand way of doing it. Back along here for the shorthand way. So for multiplying powers we can add them together. I've just shown you why in the longhand version. So x cubed times x to the 5 is x to the 8. X squared on the bottom, and when we're dividing powers I'm going to just take them away. Again, I've just kind of demonstrated why. So x to the 8 over x to the 2 is x to the 6. So 5b, similar type of question. I've got to use the fact that a to the m multiplied by a to the n would be a to the m plus n here. So 3a to the negative 1/3 multiplied by 4a to the 4/3. We would do the large numbers first. 3 4s are 12, or 3 times 4, multiplied by a to the negative 1/3 times a to the 4/3, which would be a to the negative 1/3 plus 4/3. So 3 4s are 12, that would be 12a to the 1, which is just 12a. Anything to the power 1 is just itself. And that is outcome 1 complete.